So continuing with states of matter, we now discuss the gas laws. That is, first law is defined Boyles law. And give its applications. So Boyles law, it states that at constant temperature, the volume of given mass of gas is inversely proportional to its pressure. So V is inversely proportional to P, or PV, that is equal to constant K. Or we can also write P is inversely proportional to V. Graphically, if we want to demonstrate this law, we'll plot a graph between V, volume in liters, against pressure 1 by P, atmosphere inverse will be the unit here. We get straight line. Similarly, if we plot a graph between P, that is pressure in atmosphere, against 1 by V, that is volume, liter inverse, then again we are getting straight line. Then if we plot a graph between product P1, V1 at temperature T1, P2, V2 at temperature T2, these are straight line graph. So these prove that V is inversely proportional to pressure, P is inversely proportional to volume, and in this case the product of pressure and volume at a particular temperature that remains constant, that does not change. So this demonstrates our Boyles law. Then what are the applications of Boyles law? When one goes at high altitude, suppose we are going up to a height of 10,000 meter, then one feels sluggishness or headache at higher altitude because pressure of the gas is reduced, atmospheric pressure is reduced here. Therefore, the gas that expands and the breathed air that contains less quantity of oxygen, that's why we feel headache, we feel sluggishness, and we feel problem there at higher altitude. This is the application of Boyles law. Then we have the second important law defined and derived, Charles law. Give its applications. Now what is Charles law? It states that at constant pressure, the volume of given mass of a gas increases or decreases by 1.273 of its original volume at 0 degree centigrade through 1 degree centigrade rise or fall of temperature. Let us see its derivation. If we have a gas sample whose volume is V0 at temperature, the room temperature, and temperature of the gas is raised to T1 degree centigrade, then its volume becomes V1. So V1 total volume will be now equal to V0 plus V0.273 multiplied by the temperature which has increased. Or this can be modified as 1 plus T1 upon 273, or we can write it as into V0, or we can write it as V0 273 plus T1 degree centigrade upon 273 or this is equal to V0 T1 upon 273. This is our first equation. V1 will be now equal to what? V0 T1 at 273 Kelvin. Then V2, if V2 is the volume at temperature T2 degree centigrade, then we'll be having the expression, this will be V0 T2 upon 273. Because 273 plus T1 degree centigrade, it is T Kelvin. Now dividing 1 by 2. This is equation number 1, this is 2. 1 by 2, what we get? V1 upon V2, that will be equal to T1 upon T. Or V is proportional to T at constant pressure. Now what are the applications of Charles law? This is our Charles law, we have proved it. Now what are its applications? This law helps us to derive the concept of absolute zero. Now what is absolute zero? Absolute zero is the temperature at which the volume of the gas, it appears to be zero. So that will happen only at minus 273 degrees centigrade. So what is absolute zero? It is the temperature at which the volume of the gas, it appears zero. So let us calculate this, and this volume is temperature in that case should be minus 273 degrees centigrade. So let us take the Charles law, V0 plus T1 degree centigrade upon 273, 1 plus, it was like this. So now we put the value of temperature, that is 1 plus minus, it will be 273 upon 273. So this will be equal to 0. So you can say that at temperature minus 273, the volume of gas sample appears to be 0. So this is also called as absolute zero. This is also called as absolute zero. So in this case we have driven that at absolute zero or minus 273 Kelvin, the volume of the gas, that will appear 0. Now we have the second application of Charles law. During summer season, the temperature of the surrounding, it is more, and according to Charles law, at constant pressure, when temperature is more, volume of gas will increase. Therefore tires of the vehicles, they are inflated to less pressure in the summer season, because due to high temperature, the volume of air filled in the tire, that will increase, and it will result in the bursting of the tire. Therefore tires of the vehicle, they are inflated to less pressure during the summer season. Then we have the third law, that is GasLawsTc law. Define and derive GasLawsTc law of gaseous volumes. Now what is GasLawsTc law of gaseous volume? It states that at constant volume, the pressure of given mass of gas increases or decreases by 1 upon 273 of its original value at 0 degree centigrade through 1 degree centigrade rise or fall of temperature. Let us take a gas sample whose pressure is P0, then at temperature T1 it will be equal to P0 upon plus P0.273 multiplied by T1 degree centigrade. Or we can write similar manner as we did in case of Charles law. P1 will be equal to P0 1 plus T1 degree centigrade upon 273, or this will be equal to P1, that will be equal to P0 273 plus P1 degree centigrade upon 273, or P1, this will be a volume, or this will be equal to P0 T1 upon 273. This is first expression. Then P2 is the pressure at temperature T2, then we will be having P2 will be equal to P0 T2 upon 273. This is equation number 1, this is 2, this is 1. Dividing 1 by 2, we get P1 upon P2, it is equal to T1 upon T2, or P is directly proportional to temperature at constant volume. So pressure is directly proportional to temperature at constant volume. This is our third gas law. Then we have fourth gas law, that is Avogadro's law. Fourth question is define Avogadro's law. Avogadro law states that equal volume of all the gases under similar conditions of pressure and temperature, they contain equal number of molecules or equal number of moles. So we can say V is directly proportional to number of moles of the gas, molecules of the gas, or number of moles, or V is proportional to N. So up to now we have four laws. First was Boyles law, V is inversely proportional to pressure. Then we Charles law, V is directly proportional to temperature. Then we have GasLawsTc law, P is directly proportional to temperature, and in Avogadro's law we got V is directly proportional to number of moles of the gas. So now we'll be deriving ideal gas equation by combining three laws. So now we get the question, derive ideal gas equation. So taking three laws, first of all we know Boyles law. It states that V is inversely proportional to pressure at constant temperature. And Charles law states V is directly proportional to temperature at constant pressure. Then we have Avogadro's law. It states V is directly proportional to number of moles at constant temperature and pressure. So V is proportional to Nt upon P, or PV is proportional to Nt. Removing sign of proportionality by gas constant R, we get PV is equal to nRT. This is our ideal gas equation. If N is equal to 1 here, then PV must be equal to RT. This is ideal gas equation driven with the help of three laws: Boyles law, Charles law, and your Avogadro's law. This equation is applicable to ideal gases under all the condition of temperature and pressure, and it is not applicable to real gases under all the conditions of temperature and pressure. So after defining this, we'll be now defining some critical properties of the gases. They are critical temperature, critical pressure, critical volume. So what is definitions? Question number 6. Define TC, Vc and Tc. These are called as critical temperature, critical pressure, and critical volume. Now what is critical temperature? Critical temperature, it is defined as the temperature above which the gas cannot be liquefied, how so high pressure may be, and Tc is equal to 8.27 rp. So Tc 8 a upon 27 r. B and A, they are van der Waals constant. We have already defined these constant. Then we have critical pressure. It is the maximum pressure, minimum pressure required to liquefy a gas at the critical temperature. क्रिटिकल टेम्परेचर के ऊपर कम से कम कितना प्रेशर चाहिए किसी गैस को लिक्विफाई करने के लिए, दैट इज कॉल्ड एज पीसी. पीसी इज इक्वल टू ए अपॉन 27 बी स्क्वायर. So A upon 27 B square. Then we have critical volume. It is the volume occupied by 1 mole of gas under critical temperature and critical pressure. Vc is equal to 3P. So these are three important properties of the gases which are likely to be discussed. Then we come to the next state of the matter in this chapter, that is the liquid state of the matter. Our next question will be define liquids. And discuss their properties. So as we have defined gases, just like that, liquid is homogeneous state of matter having definite mass and volume but no definite state. Now, what are the properties of liquid? Number one, definite mass. All the states of the matter, they have definite mass. As we know that mass depends upon the quantity of matter contained in the system. Since in solid, liquid or gases, the quantity of matter that cannot change, so they definitely have the definite mass under all the conditions of temperature. So this is first property of the liquid. They all have definite mass and they have definite volume. Since intermolecular forces in the liquid molecules, they are moderate between gases and solids. The empty spaces, they are moderate between gases and solids. Therefore, volume of the liquid, that is fixed. That spaces, they cannot be increased or decreased under similar conditions of temperature and pressure. That's why liquids have definite volume. Then we have the third property of the liquid, that is diffusion. As we know, gases are capable of showing diffusion. The liquid molecules also have the tendency of diffusion, but it is less than those of gases because they have stronger intermolecular forces as compared to the gases. Therefore, diffusion capability of liquids, that is less than gases, but it is more than that of the solids. Then we have the fourth property, that is evaporation of the liquids. It is defined as the phenomenon of formation of vapors of the liquid below its boiling point. The vapors, in case of the evaporation, they are formed from the surface. Since the kinetic energy of the surface molecules is more than those of the molecule which are present in the interior of the liquid, so when their kinetic energy becomes high, they start moving out of the liquid in the form of vapor. This is called as evaporation. And what is the result of evaporation? Evaporation always causes cooling. Whenever liquid is evaporated, it is accompanied by the cooling process. Now, what are the factors which affect evaporation? So these are the factors. Number one is nature of liquid. The intermolecular forces, if they are weak, liquid is evaporated at a fast pace. For example, petrol, it will be evaporated at a very fast pace because of intermolecular forces are weak. Similarly, in case of the acetone, we have very weak van der Waals forces. That's why acetone can also evaporate at a fast rate as compared to water, which has hydrogen bonding among its molecules. Then we have temperature of the liquid. If temperature of the surrounding or liquid is more, evaporation that will take place at very fast rate. Then we have viscosity of liquid. If it is more, evaporation is slow. Then we have surface tension of the liquid. If surface tension is more, evaporation is less. Then we have surface area of the liquid. If liquid is boiled in a container having more surface area, the rate of evaporation that will be more easy. Then after doing evaporation, we come to another property, that is enthalpy of evaporation. When 1 mole of a liquid is evaporated, the heat consumed for evaporation for 1 mole of liquid, that is called as enthalpy of evaporation. Then we have fifth property, that is called as vapor pressure of the liquid. It is the pressure exerted by the vapors of the liquid on the surface of liquid when they have established an equilibrium with the liquid phase. So the pressure of the vapors at the surface of the liquid when they are in equilibrium with the liquid phase, this pressure is called as vapor pressure of the liquid. It also depends upon the same factor, nature of the liquid. If forces are stronger, vapor pressure will be less. Temperature of the liquid, if it is more, then vapor pressure will be high. Viscosity or surface tension, if they are high, vapor pressure will be low, because they have the stronger intermolecular forces and will interfere in the vapor forming capacity of the liquid. Surface area of the liquid, if it is high, then vapor pressure will definitely more. And enthalpy of vaporization, in place that we have enthalpy of vaporization in place of enthalpy of evaporation. So it is the amount of heat absorbed for the evaporation of 1 mole of a liquid. So these are the properties of the vapor pressure. Then we come to the boiling point of the liquid. All these properties, they are similar and are governed by same kinds of factors. Now what is boiling point? It is the temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure. At that moment, the liquid starts boiling. Now what are the factors? The same factors are there. Nature of the liquid. If intermolecular forces in the liquid molecules are weak, then boiling point of the liquid will be less. It will be boiled easily, or we can say the liquid will be more volatile. Then similarly, temperature of the liquid, if we are having more temperature, room temperature or temperature of the liquid, then boiling point will be less. It will be boiling earlier. And then we have viscosity or surface tension. If they are high, definitely boiling point to rise. Surface area of the liquid, if it is more, the boiling point liquid will boil earlier. It will be boiled easily. Then we have enthalpy of evaporation. Then we have enthalpy of boiling also. So it is the heat required to boil 1 mole of the liquid, that is called as enthalpy of boiling. Then we have surface tension of the liquid. It is that property of the liquid by virtue of which its surface behaves as a stretched membrane. एक खिंची हुई membrane की तरह वो काम करती है, and this is due to the internal force of attraction. The molecules which are present on the surface of the liquid, they are dragged downward by the molecule which are present in the bulk of the liquid. So the surface of the liquid, it has net inward pull by the liquid molecule which are present in the internal to it. This property of the liquid by which its surface behaves as a stretched membrane, this is called as surface tension. Then how surface tension is measured? It is also measured in terms of the energy required to increase the surface area of the liquid by unit area. This is called as surface tension, or it is also defined as the force in newtons per meter acting perpendicular to the tangential line drawn on the surface of the liquid. Its units are Newton per meter because it is the force in Newton per meter acting perpendicular to the tangential line drawn on the surface of the liquid. Therefore, its units are Newton per meter or dynes centimeter inverse or dynes per centimeter. Now, what are the factors which are affecting surface tension? Nature of the liquid is also here. If intermolecular forces in the liquid molecules are strong, surface tension of the liquid that will strong. If we compare glycerin with water, the surface tension of glycerin will be more as compared to water because the intermolecular forces in glycerin liquid are stronger as compared to water. Then after this we have the temperature of the liquid. If temperature of the liquid is more or temperature of surrounding is more, surface tension will be less. Then we have the nature of the liquid, temperature of the liquid, then nature of the liquid molecules. If nature of the liquid molecules, it is to be seen especially here. If molecules are straight chain, they will be having strong intermolecular forces because they have more area of contact. If they are branched chain, then they will be away from each other, intermolecular forces will be weak and surface tension will decrease. Now, what are the applications of surface tension? The spherical nature of the liquid drops. It is because of surface tension, because the molecules which are present in the center of the liquid drop, they are attracting, they are exerting inward pull on the molecules which are present on outer side of this drop. Therefore, drop assumes a spherical shape. Then we have the cleansing action of soaps and detergents. The soaps and detergents, they are the surface active reagent. They get concentrated on the interface of the dirt and water, and they lower the interfacial tension between dirt and water and form a stable emulsion at the surface of the cloth. When the cloth which has been washed with detergent or soap, or the cloth on which soap or detergent has been applied, it is washed with your fresh water. This stable emulsion of detergent, dirt and your water, it will be washed away and leaving our cloth clean. Similarly, cleansing action of the your toothpaste, that also depends upon the same factor. It is the lowering of surface tension by the material of the toothpaste and which clears dirt from our teeth. Then we have the next property of the liquid, that is called as viscosity. It is that property of the liquid by which a liquid layer resists the motion of the other liquid layer which is running above it. So viscosity, it is the frictional resistance to the flow of liquid is called as viscosity of the liquid, or it is the internal friction or resistance which one liquid layer offers to another liquid layer. Then we have another important definition, that is called as coefficient of viscosity or power of viscosity. We can say coefficient of viscosity, it is expressed by eta. So coefficient of viscosity, it is defined as the force in newtons per meter square required to maintain a velocity difference of meter per second between two adjacent liquid layers which are separated from each other through 1 meter. Though liquid layer which are separated from each other by 1 meter, how much force in newton per meter square is required to maintain a velocity difference of meter per second between these two liquid layers? And it has been seen that coefficient of viscosity, it is equal to A, that is surface area of the liquid, upon frictional force which is decreasing the velocity of the liquid upon dV upon dx. This is the velocity gradient of the liquid layer. So this is our coefficient of viscosity, that is A upon F multiplied by dV upon dx. So F is frictional force, A is area, eta is the coefficient of viscosity, dv upon dx is the velocity gradient. Now what are the factors affecting viscosity? They are same nature of the liquid. If liquid molecules have stronger intermolecular forces, the liquid is likely to be more viscous. Then if they are branch chain molecules, then liquid is more viscous. Less viscous if they have linear molecules, then the liquid will be more viscous. Then we have temperature. Higher the temperature of the liquid, higher will be the viscosity of the liquid. And thirdly, we have the pressure of the liquid. If we have the high pressure on the surface, then viscosity of the liquid that also increases. Then what are the differences between evaporation and boiling? We have defined both the characteristics. Evaporation, it is the formation of vapors of the liquid, that is from the surface of the liquid. But in boiling, vapors are formed from the bulk of the liquid, from the bottom of the liquid. Evaporation takes place at all the temperatures, whether boiling point of the liquid has reached or not. Evaporation occurs at all the temperatures, so it is spontaneous process. Then boiling takes place at definite temperature, that is boiling point of the liquid. It does not have occur at all the temperatures. Then why boiling point of the liquid increases? When pressure or at the surface of the liquid is increased. We have already defined that boiling of the liquid takes place only when vapor pressure of the liquid becomes equal to atmospheric pressure. If the atmospheric pressure or the pressure on the surface of the liquid is increased, then we require more heat, more temperature to increase the vapor pressure of the liquid. That's why the boiling point of the liquid that will also increase. Now what happens at hills? If we cook rice, they will not be completely you can say cooked at high altitude, because pressure is less. When pressure is less, water boils at less temperature, and cooking temperature of the rice that does not reach under that condition. Therefore rice remain uncooked at higher altitudes. Then we have drop of liquid. Meniscus is spherical, so we have already discussed this property. Then level of mercury in capillary tube is lower than that of the mercury outside the capillary tube. So it is experienced because of the cohesive forces. The forces which are operating in the molecules of the mercury, they don't allow the mercury to rise in the capillary to a higher level than the mercury which is present outside the capillary tube. So these are the cohesive forces which are resisting the movement of the mercury in the capillary tube. Water meniscus in a glass tube is concave, while that of mercury meniscus is convex. The reason is same. In water molecule, the intermolecular forces, that is hydrogen bond, they are stronger. That's why the water molecule, they have concave meniscus in the capillary tube, while in case of the mercury, the interatomic forces, they are weak as compared to forces of adhesion, that is the forces operating in the molecules of mercury and glass. That's why we see the convex level in the mercury and concave level in water. Then liquid like ether, acetone, etc., they are kept in the cool places. The reason is they are more volatile, they have less boiling point. So if they are kept in the hot condition, they will get vaporized easily. That's why they should be kept in cool case. Then evaporation causes cooling. It is because of whenever molecules evaporate from a surface, they take up energy from that surface. So when energy loss takes place from the surface, it automatically results in the cooling of that surface. Now what is the effect of temperature on density? As we know, density is mass upon volume. When we heat a liquid, then what will happen? The volume of the liquid tend to increase, therefore density will decrease. Then we have the surface tension, it will be decreasing with the increase in temperature. Viscosity will also decrease, and vapor pressure of the liquid, that will increase by increasing temperature. Then name the liquid which has high vapor pressure out of alcohol and glycerin. We know alcohol have weak forces as compared to glycerin, which has very intense hydrogen bond in glycerin. Therefore, alcohol will have high vapor pressure at any temperature as compared to glycerine. Then out of petrol and kerosene oil, we know petrol will have high vapor pressure as compared to kerosene. Similarly, comparing mercury and water, we'll find water will have high vapor pressure as compared to mercury. So these are the some objective type question from the states of matter. So this finishes our unit where we have discussed two states of the matter. Solid state not discussed here because that will be discussed in the 12th level. We have a complete chapter of solid state in our 12th class. So this is all about states of matter. Tomorrow we will take up with a fresh chapter, that is chemical thermodynamics. Thank you very much.